So hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet, and in this we were doing linked list topic. Inside that we were doing reversal pattern. Today we'll do the next question, which is swap nodes in pair, where the reversal logic will help us to solve this question. So let's read the problem statement. The question says we will be given the linked list, as you can see 1, 2, 3, 4, and we have to reverse the linked list, but in pairs. Every two elements or nodes we have to reverse. So if 1 and 2, think as a entire linked list. So how 1 and 2 will get reversed? So that it will become 2 and 1. Similarly 3 and 4 will get reversed and become 4 and 3. So then after reversal you have to return the new head of this linked list, which is 2, correct? So let's read the constraint. Constraint says the number of nodes will be 0 to 100. Why we read the constraint? Because the number of operations when it goes beyond 10 power 8, or for sure beyond 10 power 9 or at 10 power 9, it gives TLE. How I said that? Because we have learned about time and space complexity earlier. I'll attach the link. But in this case, as you can see, the number of nodes are very small, and anyhow in linked list linear solutions work both as a brute force also and optimized also. So let's see in this case, like for this condition, how we'll solve. So here is a problem statement. Suppose we don't know how to reverse linked list, okay? So by default, like brute force approach, how can you do that? Think you don't have linked list, okay? Assume that you don't have linked list, instead you had list, okay? You had list. What do you think? How can you swap these? Can I say ith index and I plus 1th index I will swap? Then again I will move I plus 2 instead of I plus plus, correct? So when my I will be here, it will swap with this. Now next time I will be here, it will swap with this, and that's it. Yes, but if we have to do with linked list, how we will do? Very simple. Means start your current pointer from here, because you know we never mess with head. If you will move head ahead, then how or who will take care of the original head? Means you will lose your linked list. So hence always prefer to make alias. Now once done, we will make a list, and one by one we will read the value and put it here. Now next time we will move current, read the value and put it in the list. Similarly 3, and next time 4, and once the current hits null, we will stop. So this is a list we are ready with. Now what? We will start our while loop condition, means, or for loop. Let's say for loop we will start from int I is equal to 0 to I less than total length minus 1. Why minus 1? Because you know I will be here or I will be here, correct? So that is why it is very important to run till the second last element, and I plus 2, correct? Yes. Now what we will do, in our temporary we will save whatever is there at list dot get I. At ith index what we have? 1, so 1 will get save here. Now at list we will set at ith index, but what we will set? Whatever is there at I plus 1th index, correct? Means 2 you have set here. Now at this location, means I plus 1, what you have to set? Whatever is there at temporary variable. So we will write list dot set what? At I plus 1th index, and value will be whatever is there we have stored in our temporary. So this much line of code, which actually takes O of n by 2 time complexity, which is linear only, this will help us to swap this list. So let's write after swap. So this will become 2, 1, 4 and 3. Now what? Now again we will start our current pointer, yes, and one by one we will read the values from the list. So it is 2, we will overwrite the value of the node. Now this is 1, we will overwrite. This is 4, we will overwrite, and this is 3, we will overwrite. And whatever was our previous head, this we will return. So in total, how much time complexity it took? First the O of n to read the values from node and fill in the list. Further O of n by 2 to swap the nodes in the list. And then again further O of n to put values again or override the values of the node. So in total O of n plus n by 2 plus n, which is O of 5n by 2. Can I say that? Anyhow it is linear only, but the time complexity, to be more precise, it's 5n by 2, and space complexity is O of n. Why? Because we are using or taking this extra array list to save or swap the nodes. So can we write the code for this? So here is the code I have written for you all. First, the base case. Why? Because if you see in the constraint, the question says the number of nodes can be 0 also. So what do you think? If the number of node is 0, definitely we have to return null, means head only, which is null. Now if the number of node is 1, means head is there but head dot next is not there, means alone 1 is there, like this. Okay, so does it make sense to swap this linked list? No. At least if there are 2 nodes, then it makes sense to swap the node so that it will become 2 and 1. So hence, if your head is null or head dot next is null, we will return whatever our head is. Now we'll create our list, array list, and the alias current, which will start from our head. Now we will run the current until it becomes null, and we will read the values and put in the list. So this much line of code, which will take O of n time complexity to fill the list. Now this for loop we are taking, means these 3 lines of code are helping us to swap the values in the list. Once done, which is actually taking further O of n by 2 to be more precise. And then again we are starting our current from head, and one by one until the current becomes null, we will read the values, swapped values which is present in the list, and we will put in the current value, means the node value we will change. We have not reversed the linked list, we have just changed the value itself, and at the end whatever is the head we will return, correct? So this will take total O of n further time complexity, correct? So let's run the code and let's try to submit this. So this will also get submitted faster only because this is linear, correct? Yes, but this is taking extra space complexity, means can we do this without extra space? That is called in place linked list solution. Yes, we can do that, and the idea is very simple. Let me show you how. See, to swap it, first we have to be present at this node. Let's say first, and we have to be present at this node. Let's say second. Why this? Because 1 next needs to be connected with 3, because after swapping when 2 will come here, 1 should get connected with 3. Can I say? Forget about this swap. I'm not worrying about this swap. I'm just worrying about this much. Okay. Yes. So that is why first needs to be connected with second dot. And one more thing is, we will start our dummy node from here. Let's call it previous pointer. This will always be standing 1 pointer behind the first and second, which we have to swap. Now the idea is very simple. You know, after swap, first next should connect to 3. Can I say? Let me show you after reverse how it will look like. 2 will come here, 1 will go here, and 1 will connect it to 3 and 4. I am just worrying about this much swap, not towards right side. Okay. So I have to connect my 1 to 3. So how, like what line of code I should write? What do you think? Very first is ki first dot next, I want to connect this to second dot next, correct? So can I say this will get, so can I say this will get connected to what? 3. That's what we wanted also. 1 is connected to 3. Yes, yes, but 2 is also connected to 3. And what I want my 2, means second dot next, connected with first, correct? So we will write here second dot next, we will connect it with first. See, linked list is very easy. It's all about how you are actually recognizing and taking care of the nodes and pointers. Okay, it might felt confusing initially ki how can we swap, but I am just showing you one by one how we will think, and if we will get stuck, we will fix it also. Okay, so what we did, second dot next we have connected with first. What does it mean? Second dot next means this, we want to connect this with what? First. Okay, so can I say 2 is connected to 1 and 1 is connected to 3? Can I say like this? And where my previous was pointing, let me tell you, this is first. Okay, we have not changed the pointers, and this is still referring to second. Okay, and this was my dummy node, right? So if you still feel ki dummy node is connected to 2, no, dummy node was connected to what? 1, correct? So let me show you how. So somewhere here dummy node will be sitting and it is connected to this, and this is what? Previous. Okay, but to make it linear, what we want? We want this to connect with this, na? correct, 0 with this, then only I can say na yes, swapped, and dummy is sitting wherever it was sitting earlier, correct. So what I should do, dummy is nothing but previous, so currently previous dot next is connected to first. I want this needs to be connected with 2. How can I write? Dummy dot next means previous dot next connect with what? Second, correct? Yes, very simple. So previous dot next is equal to what? Second. Done. Now what will happen? This will get disconnected from 1, okay, and dummy node 0 will get connected to 2, and this is previous. Now can I say this has been reversed or swapped? Yes, we can. Now for 1 and 2, previous was sitting 1 behind. So for next 3 and 4, what do you think? Where should previous sit? Can I say 1? Yes. So now next line of code will be what? Previous is equal to first, and that's it. And we will keep doing this again and again, means inside the while loop. But now the question is, inside the while loop, what should be the condition? Means, again, listen, what if 3 and 4 is not there? So can I say if my, like previous is sitting at first, right? So if my previous dot next is null, stop. Can I say that? Think again. Yes, because I don't want anything, I don't have anything to swap with, correct? Yes. Now suppose 4 is not there. Suppose only 3 is there. Where is your previous is at first? Why? Because you just shifted your previous to first. Now previous dot next is there, but no further node is there, means 1 and 2 has been swapped. Do you think 3 needs to be swapped with someone else? Think again. No, correct. So can I say previous dot next is null or previous dot next is null? If any of these are null, we can say key stop, correct. Until then, if not null, then keep doing this. Yes. So in the while loop, what we will write? In while loop, while my previous dot next not null, and what? Previous dot next not null, correct. We'll keep doing these many steps again and again. Now what will happen? After coming out, what do you think? Should we return head? No. Why? Because head was pointing to 1. If we will return head, it will return 1 and 4, 3 after swap. What about 2? That is why we created a dummy node, because dummy node is there. So now instead of returning head, we will return dummy dot next, okay, and we are done. So let's write the code in the code editor. So what we will do, first we will make list node, let's say dummy, okay, is equal to new list node, and value will be, let's say, 0. Now we want the dummy dot next to be connected with head, so that the linked list will look like 0, 1, 2, 3, 4, correct. Now what? We have to start a list node, let's say previous, from where? From dummy. Done. Now what we will do? We have to write ki while our previous dot next not is equal to null, along with that previous dot next not is equal to null, okay. Means if we have 2 nodes, then only swap. Now inside this we have to start list first will point to head. Instead of head, let's call it previous dot next. Why? Because first will always become, see here, currently so we are making this first, correct. So we can say now though it's head, but when this much swap is done, so previous will point to here. Can I say? Yes. So I want this to be first, so if we will write with head, again it will become 1, correct. So that is why first will be previous dot next and second will be previous dot next, or we can say first dot next, correct. Now list node second is equal to first dot next. Done. Now we have created this. Now what we have to do? We have to disconnect and connect, like the real swapping will happen now. So what we have to do? First we have to connect ki first dot next needs to be connected with second dot next, and what? Second dot next needs to be connected with first, and previous dot next needs to be connected with second, and previous needs to be moved at first, correct. Now after coming outside, we have to return dummy node dot next, and we are done. So let's run the code. Yes, and now let's try to submit this. So you can see the time complexity will be O of n because you are just moving for one iteration. In the previous case, it was 5n by 2, although it is linear. But in linked list, more than n, like 2n, 3n becomes brute force approach. And when we optimize in single iteration or half iteration, it becomes the optimized approach. And also in this case, we are not taking any extra space. So that's why this is the most optimized code. So this was in the Java, and here is your C++ code with a similar approach, and here is your Python code with a similar approach. So if you understood the reason of both brute force and optimize, then definitely you are eligible to mark the next question also as done in the sheet. So guys, that's it for this video. If you have any doubt, any concern, please do reach out to me in the comment section, or you can reach out to me through social medias also. And please do hit the like button and subscribe the channel if not yet subscribed, because we are learning DSA not just to solve problems but to understand with patterns. That's it. Let's meet in another video with some more interesting questions, topics and patterns. Till then, keep learning, take care of yourself and your family.